Hi, it's Mrs. Pope, and today we're going to be talking about absolute value inequalities. So a little different than equations, these are inequalities. So we're dealing with greater than or less than, or greater than or equal to, or less than or equal to. So we won't see any actual equal signs today, they'll all be greater than or less than signs. So our goal is to solve and graph absolute value inequalities. So you're going to be given an absolute value. Absolute value, remember, this is when you have the brackets around here, it's the distance a number is from zero, so it's always going to come out positive. So we want to solve and graph these types of inequalities, and we're graphing on number lines. So we're going to be doing number lines when we graph these. Okay, so when you have example 1, solve and graph the absolute value of x is less than 3. The way we do these, we're going to always make two different equations. The reason that is because absolute value of x, just think, that could be negative 3, and if I took the absolute value, it would just be 3, or it could be positive 3. If I took the absolute value, it would just be 3. So the reason, that's why we set two of them up, because absolute value, this value actually could have been negative or positive 3, so we need to look at two possible options. So our first equation, what you do is you write it exactly as you see without the absolute value bars. So x is less than 3. Haven't changed anything, just took out the absolute value bars. The second one that we're going to solve, we have x is, we need to flip the sign and negate the number. So we're going to flip this, instead of less than, it's going to turn into greater than, and then instead of 3, it's going to be negative 3. So this is the trick here. The first one, you always write exactly as you see without the absolute value bars. And then the second one, you flip the sign and negate the number, or negate whatever is on the other side. So these are already solved, there's no other variables, so we just need to graph them. So we want to graph x is less than 3, so we're going to want to go to 3, open circle, because it's not or equal to, so we have an open circle on 3, and we want to graph what's less than that. But we also want to consider, we're talking about both of these, so when x is greater than negative 3. So I'm going to put both of my numbers on here. Here's negative 3, here's 3. I want to shade less than 3, so all of this would get shaded, but I need to keep in mind I need to be greater than negative 3. So I'm not going to go any further down than the negative 3, so I'm just shading in between negative 3 and 3. So for example 2, it says solve and graph absolute value of x is greater than 5. So we have the two different equations. X is greater than 5, that's just the same without the brackets, and x is less than negative 5. So I flipped the sign, negated the right side. Let's graph both of these. So we have 5 and negative 5 we're dealing with. They're both open circles. And x is greater than 5. So if I want to shade greater than 5, that's everything over here. But here I need to graph x is less than negative 5. So that's everything here. So you have this or that. So this one, greater than 5. This one, less than negative 5. So we have these two graphed. Let's look at some more examples. All right, so example 3 says solve and graph. We have a little bit more. We have a multi-step inequality to solve. Absolute value of 6y minus 5 is greater than or equal to negative 13. Same steps. Make two equations. One, exactly the same without the brackets. The second one, flip the sign, negate the right side. So if we were to solve these, we have negative 5. I want to get y by itself, so we're going to add 5 to both sides. So 6y minus 5 plus 5 greater than or equal to 13 plus 5. So these cancel each other out. 6y is greater than or equal to 18. Divide by 6, divide by 6. Y is greater than or equal to 3. So that's one of them that I'm going to use, and now we need to solve the other. So here we need to do the same thing, add 5 to both sides. So the original equation, 6y minus 5 plus 5 less than or equal to negative 13 plus 5. And just notice I'm writing them linearly. That's why we have them all. I just rewrote it. So negative 5 plus 5, 6y less than or equal to negative 8. And then we need to divide by 6. Y less than or equal to, and at this point you can keep it as a fraction, you can reduce the fraction. My suggestion is to turn it into a decimal. It's a lot easier to graph or see where decimals may lie on a number line. So if you divide this, that would really be 4/3, negative 4/3, or negative 1.3 repeating. So now I need to graph both of these. Y is greater than 3, and y is less than or equal to negative 1/3. So let's go to 3, and I actually have a closed circle because of the or equal to. I need to include the value of 3, and y is greater than that. So I'm going all the way here, everything to the right. And then I have y is less than negative 1.3. So here's negative 1, here's negative 2. Somewhere in here, let's call this negative 1.3. We have a closed circle. Doesn't have to be exact, but we make sure it's between the right two integers. And then we want to shade everything less than that. So we're going to have this or that. They're both part of the solution set. All right, last example for this one. Example 4, absolute value of 5z, that's z plus 2 is less than or equal to 17. Make your two equations. If you'd like to pause and do it while I'm doing it and then come back and see if you got it correct, feel free to do so. So my first equation, 5z plus 2 less than or equal to 17. My second equation, 5z plus 2, flip it, must be greater than or equal to negative 17. All right, so when we're solving here, just regular multi-step, like you would say, or solve regular multi-step equation, we need to subtract 2 from both sides. So we have 5z plus 2 minus 2, less than or equal to 17 minus 2. These cancel out. 5z less than or equal to 15, divide by 5, divide by 5. Z is less than or equal to 3. So this one is solved. Subtract 2 from both sides here. 5z plus 2 minus 2 is greater than or equal to negative 17. And then these cancel out. 5z greater than or equal to negative 17. Oops, minus 2, minus 2. 5z greater than or equal to negative 19. Divide by 5, divide by 5. Z is greater than or equal to. Again, I think it's easier to go ahead and turn it into a decimal, unless you know where to grab 19/5. And that's going to be negative 3.8. All right, so if we were to graph these, go ahead and graph them. Find z is less than 3, so I want to go to 3 on the number line. Have a closed circle, and I need anything less than 3, but let's be careful because z must also be greater than or equal to negative 3.8. So here's negative 3. Let's call this negative 3.8. So I have a closed circle. So it has to be in between these two values. Thanks for watching, and remember, you are responsible for your own learning.